Hello guys, how you guys doing? Today we are going to be going over the application of integration, and this is actually one of the easiest lectures, I would say. There isn't really a lot to cover since it's mostly equations that are given, and so let's start right into this. I'm not going to really explain how or where we got this equation from since it's a given. I'm just going to show you guys how I use it, and you guys can conclude your own understanding. I'm going to try to explain how it's used and what are the steps you need to take in order to use it properly, and you guys can conclude on your own whatever your math process is in your head. The couple things you want to know is our p. So for this equation, our p and g are constants. All right, and that is because our g equals 9.8, which is gravity. If you're familiar with this is meters per second squared. If you're familiar with physics, and our p, if the length is in meters, it's 1,000, and if it's in feet, then p and g is 6.25, 62.5. And so now that we just went quickly over that we just have constants. What are dy and wy? Your dy is just like your dy dx. That's the term you're integrating in terms of. We're integrating in terms of y, right? And so your wy is the width of the object we're going to be working with, and your dy is just the function, right? And so usually for these questions, the first question is that we don't really have a equation. And so since it's okay, so let's first let's start with the drawing. Suppose that a thin plate that is 8 meters wide, so 8 meters wide, and then 3 meters tall. So it's just 8 meters wide and 3 meters tall, right? So 8 meters, 8 meters, that is a horrible, man. 8 meters and 3 meters tall, right? And it says is immersed vertically in water 1 meter below the surface. So surface, and this is going to be water, right? And we know it's under the water by 1 meter. Okay, express the force on the side of the plate as an integral and evaluate it. Okay, so we're looking at the force that is pushing on the side here. And so the equation, we're going to do the math on here. The equation that we were given up top right here says f equals the integral between b and a, or from a to b. And then we have our p and g, which is constants. We have our dy, and we have our wy, and we have dy, right? So like we said, your bound, so it is written here, your bound a and b, where the strips begin and where the strips end. Now always make your water level y equals 0. It makes your life a lot easier, okay? And so what it says here, where this strip begins and end. It begins at y1, right? This is 1, so we go 1 deep, then it begins. So it begins at 1, and it goes all the way to, so this is 3 meters tall, plus this one, it goes all the way up to 4. My p and g constants, and this is given in meters, so my p is 1,000, my g is 9.8. My dy is just a function of y, right? This is linear, so it's just y. And then my width, I have it as 8 dy. And then from here, you can integrate. Now this is constant, so this can come outside. The 8 is also constant, it can come outside. So what I'll get is f equals from 4, actually, it's p, g, 8, and then the integral 4, 1, y dy. And you can integrate from here, okay? Now when it comes to a question like this, where, as you can see, the sides are not straight, right? And so our function is not just a y anymore. It's an actual function, like a y equals mx plus b, right? Or a function that's like x squared, like functions that represent a certain shape, right? And so how do we get this function? First, let's set up our values. So first, the equation we have is f equals the same equation, right? Pg, this is in meters, so it's 1,009.8, and then times our d, and then times our width, and then times dy. Okay, Now we know obviously PG is constant, so it'll always come outside. Now what is my A and what is my B? Like we said, A is where you start, B is where you end. So A is gonna be so here we're gonna set y equal to 0, remember? Water level is always 0, or the top is always 0. And so not like you can set it to 0, but then you'll have to do some other math and set your values to different, but it's easier this way. So we know our A starts from 0. So remember up top, it started where the surface begun, which it began at 1. But this one's the surface all the way to the top of the water, so it starts at 0. And its depth is 6 meters, so it ends at 6, right? So this goes from 0 to 6. Now PG, I took it outside, right? Times, now what is our function here, right? It's still just y. That's our depth. Our depth is vertical, right? However, our width, as you can see, it's different. So the width here is different than the width here. And the width here is different than the width here. And you see, that is why we need a function for our width. But for our depth, we don't. It's just the depth of y, right? So this is y starts from 0 to 6, and the depth is from 0 to 6. And that's why it stays out with y. Now for my width, what do I need to do? The way you can figure out your width is you would first declare it as a y equals mx plus b format. So, but we're using w for width, m, and we're integrating in terms of y, not x. So this would be y plus, you can say b, or you can say any other letter, all right? And so, you know, if you remember from high school, solving for your linear m equals, or y equals mx plus b, you need 2 points on the graph, right? So our 2 points are w. Well, we know at y0 the width is 9, right? So at y0 our width is 9. So 9 equals m 0 plus b, and this would go to 0, and so we know 9 equals our b, right? Simple as that. And now that we got our b, we can declare the equation again. So y equals my plus 9. Now you can't use the same point. That's not how it works. You have to use 2 different points. And so our second point, we know when y is 6 meters deep, our width is 14. And so that's our second point. 6 plus 9, take 9 to the other side. 14 minus 9 equals m6. And I can say 14 minus 9 divided by 6 equals my m, which is 5 over 6 equals m, right? Now that I solved it, I can say w equals 5 over 6 because I got my m, y plus my b is 9. Now I take this and I sub it into my w. So this is 5 over 6 y plus 9 ui. Now you just gotta expand, so f or FOIL, right? This is 5 over 6 y squared plus 9. That's a horrible looking 9y dy, and you integrate and you take your bounds and you get your answer. All right, so moving on to the next question. So for this question on lecture, the values she gave were, this is 3 meters deep, all right, and this is 5 meters deep. It's 7 meters wide, and so as you know, you will set this won't be given, so you'll have to set this y equals 0 at the top, and assuming this is your water right here, and so this point, right, this would be 3 deep. So your width here would be 0, right? Your width is 0, and your y equals 3 at this point. All right, and then I'm gonna leave the rest to you guys. The notes are on lecture. The way that she did it is the same thing that I just did upstairs. It's the same thing that I did up here, and so it should be pretty simple and straightforward for you guys. All right. So now moving on to application of cardiac output. Another equation that is given, another sub in play, nothing too complicated. Okay, and so on the midterm, she asked like for a solution, you give her a number. Maybe on paper she'll just ask you to set it up. So I'm not sure how this would like what type of question she'll ask, or she'll maybe give you a question like this, and she'll give you a couple examples of this but filled out, and she'll tell you which one's right. Right. So if the dye dilution method is used, 5 milligrams of dye, and the concentration of the dye in milligrams per liter can be modeled by this function for between 0 to 9 seconds, find the cardiac output. So your force equals your A is what you begin with, which in our case is 5, right? All over the integral we have from 0 to 9. And then your CT, which is 1 over 3 T 9 minus T. Oops. It's a no-brainer, to be honest. It's like 3 marks, dt. And so you integrate the bottom, right? And then, so one way you can integrate is you'll expand your t. You'll get t squared, and you'll get 9 over 3t, and you can integrate that just fine. And take your bounds, and that should be it for that section. Now, coming to this one is not too spicy, to be honest. The only difference, you're using Simpson's rule. So if I were to apply the equation, that is F equals A over my T 0 and then CT dt, right? Your A will be 8, right? So I'll have 8 over, and then what is my bounds? From what to what are they asking me? And obviously I know my time here is from 0 to 24. So from 0 to 24. And then my CT, you see, the thing is, okay, I'll just write because I don't have an equation, right? So CT dt. All right. And now, if you guys remember from last lecture, we did a similar, well, it was like a car with like, it was slots like these, and it was time and velocity. And you guys did Simpson's rule on it. So you'll do the same thing. And whatever you get for this, right? Whatever you get for this, you take that value and you sub it in here. And that's about it. So that's for this one. Like I said, we did it last lecture, so I'm not going to go through it and waste your time. Now we're going into probability. So now for this, for probability, the question that she usually will ask you is something like set it up, or is this, like as you can see down here, we're going to go through it in a bit. So well, let's just set these up. She'll give you a function, and she'll give you the probability density function of it. And so as you can see here, you just give the bounds between, 20 to 25, f of x dx. Nothing too spicy. This one goes from time less. So the integral from 20. So we're going from 20, and 20 is at the top because it's bigger, and t is less than 20, to, obviously time can be negative, so 0. And that's about it. Now for more than, this is going to be an improper integral type 1, and this is going to be to infinity because it's saying 25. T is more than 25, like to infinity, right? Dx. Or here would be actually dt. F would be f of t dt in terms of time, but it doesn't really matter. Okay, so is to be honest, probability density function is not too difficult. The only thing you gotta pay attention to is the fact that not every function can be a PDF. Why? Now probability is always between 0 and 1. You either have 0 chance, or you have like 0.5, which is like 50% chance, or 1 for 100%, right? So it's between 0 to 100%. Or it's the same thing between 0 and 1. If the function results in anything more than 0 or 1, then it can't be a PDF, right? And so PDF, so here says f of x has to be more than or equal to 0 for all x. So that means it can't be negative. Can't be negative, right? So it can't be less than 0, And here it says from negative infinity to infinity, it has to add to 1. And so as to be less or equal to 1, right? So it can't be less than 0, and it has to be less than or equal to 1. So that means from between 0 and 1. That's PDFs. Now, how can you identify them? So here there's a couple questions. Which of the following functions can be a probability density function? And so you just got to check, does it add to 1 or is it negative? And so for e to the x graph goes all the way to infinity, right? And so that doesn't add up to 1. And so that's not it. Here, what this is saying is 2x if if x is more than 0 or less than 1. Otherwise, it's 0. Okay, so what this is saying basically is the integral between 0 and 1 of 2x dx, right, is between 0 and 1. And if you get anything else, it's 0. Okay, and so you can basically integrate this. And when we integrate this, I'll get 2x to the power 2 over 2. And so these cancel out, and I'll get x squared. And now when I take the integral of this, I get 1. Right? So this is from 0 to 1. And I'll do 1 squared minus 0 squared. And this is 1. And so this passes. You see? Pretty simple. Nothing too crazy. So you see, for this one here, we're saying x minus 2. Now the question is, will this ever equal less than 0 or more than 1? And as we can see, if x is 0, which is saying, you see here, if x is 0, then we get negative 2. And that is not good because it can be less than 0. And so this can't be a PDF, right? And same thing here. This is saying if x is 0 or 1 or between, then it will always be 5. And that is also not correct because our PDF can't be more than 1. All right, so nothing too crazy. All right, so when it comes to these, I don't think I'm going to really go through and waste your time on these because it's the same thing as earlier. This is your function. These are your bounds from 0 to 2, right? You take the integral. So you see in the first one, it says verify that this is a PDF. And then so, but do calculate. So when you want to confirm that's a PDF, obviously up here, we said from negative infinity to infinity equals 1. And so if you want to confirm it's a PDF, you want to set the bounds to negative infinity to infinity. And then you want to obviously see if it equals 1. If it equals 1, then it's a PDF. All right. Now your second way to confirm, your second B, so your second task, it's saying find P x less than 1. So this is the integral from negative infinity to 1. And this is obviously your function. And you want to set the bounds, do the limit since this is improper type 1, and get your PDF probability. This, same thing. You have your function. So what is your bound? It says the time between major earthquakes in the Southern California region is a random variable, the probability density function. This, where t is measured in days, find the probability that the time between a major earthquake and the next one is more than 365. So you see more than. So this is saying your time is more than 365. And so your integral is from 365 to infinity. And this is your function. Right? And then you want to sub the function in, integrate, take your bounds, find your result. And that's about it. And this will be your last lecture for midterm 1. I hope you guys do great on the exam. I'll be covering the exam materials soon for the last 3 weeks of Calc 2.